Hello, morning once again. Uncle's lovely grade 11s and grade 12s. Namuhla, your favorite Malume came with the quadratic sequence. Falls under the second topic, which are number patterns. We both do them in grade 11 and grade 12, but this one is not the linear and it's not the geometric, but it's the quadratic sequence. So I just looked at this one and decided, let's start with the quadratic, with this easy one, just to warm up our brains before we go deeper into arithmetic and geometric. So we all know quadratic means still trinomial. Okay, let's go for it. Okay, the question says, given this name, when I was still in class, this other friend of mine, when computer maths, her girlfriend was given, and I love it class, whenever we do maths, whenever the teacher says given the quadratic, then I would laugh a lot because her girlfriend will look at me and because her name was given. So whenever the teacher says given the equation, so it would be fun. So I like this name. So okay, anyway, let's continue with given. Yeah, my friend's girlfriend. Okay, given the quadratic sequence 0, 5, 14, then it continues it continues up until 779, then it says 860, meaning this is our last term, right? First term, second term, third term, then there are terms in between up until it reaches 779 and 860. That's our quadratic sequence. So let's go for the first question. Write down the value of the fourth term, which is T4 of this sequence. T4, what do they want? The fourth term. We have first term, second term, the third term, the fourth term, which is here after the 14. How do we get the fourth term? Okay, we'll rewrite this sequence and see how do we solve for the first one. How do we get the fourth term? Okay, let's call it the 2.1 solution. Okay, 2.1.1, we have our sequence, which is 0, 5, 14, 5, 14. Okay, it goes on up until the 779 and the 860. So let's look at it then. How do we deal with the quadratic? A quadratic has a first different and a second different. So before we dive deep into this, let me first explain for a quadratic. If it's a quadratic, we'll have the sequence. Then under the sequence, we'll have the first difference. We'll have the first difference, which will be arithmetic. And again, we will have the second difference, which will be constant. Your second difference must be constant. Okay, let's go on to see what am I talking about. Okay, this is our sequence here. This is our sequence. And then let's go for the first difference. So the first difference, how do we find it? we find the difference between these numbers. If we had the third one, we also put the third. Okay, so how do we find the first difference? The term number 2 minus term number 1. 5 minus 0, it gives us a 5, right? That's a 5. Term number 3 minus term number 2. 14 minus 5, it gives us a 9, right? So any other number here we don't have. Okay, so let's get, okay, meaning this is our first difference. Okay, okay, for the second difference, how do we get it? 9 minus 5, it gives us what? It gives us a 4. Okay, so but I say the second difference. Okay, this is the second difference. Second, okay, as we go on, we are at the second difference now. The second difference, we first have to do all this before we attack the first question. So but remember, I said the second difference is always constant. So meaning, even if we're looking for the difference of the previous number here, we're going to still get 4. Meaning here, whatever number there is here, there'll be the first difference, but the second difference will still be 4. The second difference is always constant. So how do we get the T4 if we have this? This is the information we now have. So we have the first difference, which is 5, 9, but on the first part of it. So we have the second difference. The second difference will help us to get term number 4. How do we get term number 4? We add our sequence number, which is term 3. We add our first difference, which is 9. We add our second difference, which is 4. Then we get term number 4. Just like here, if you can see, to get the third number here, the term number 3, they say the sequence, which is 5 plus 5 plus, you see the second difference is 4. 5 plus 5 plus the 4, which was supposed to be here, it gives us a 14. That's how they arrived to the 14. So we have to arrive to the term number 4, which they want there. Meaning we'll say 14 plus 9 plus 4 is equals to the fourth term. So let's see. Meaning let me show you this. Always know, let's just form this equation. Next term, okay, on a quadratic, the next term is always equals to the last, or this last one, which was the last one before the term you want. Last term plus the first difference, then plus the constant second difference. This is the equation. You can say this is the equation of finding the next term. The next term is always the last term, the last one before the one you are looking for, plus the first difference, which is 9, plus the constant second difference, which is 4. Then we get this term. So how do we get T4? Next term, which is T4, is equals to, our last term was 14 plus the first difference. What's our first difference there? It's 9 plus our constant second difference. What is our constant second difference? Which is 4. So T4 4 is equals to 14 plus a 9, it's a 23. Am I right? Yes, it's 23 plus 4, it's a 27, right? T4 is equals to 27. T4 is equals to a 27, meaning we now know that after 14 we go to 27. Okay, let's see. 27 minus 14, it gives us 27 minus a 14, we get a 13, meaning here if we come and try to fill in this one, it will be 13. So if you check this one, you remember I said the first difference is always arithmetic. Arithmetic is the one which has a constant difference, which our D must be the same. 13 minus 9, you get a 4. 9 minus 5, you get a 4. You see, now it now makes sense. So even if we wanted the term number 5 here, this is our term number 4. Even if we wanted term number 5, we would say 27 plus the 13, which gives us 40 plus 4. It will be a 44, the term number 5. That's how we get the next term. So let's go for the second question. What do they say? They say determine an expression for the nth term of this sequence. Whenever they say they want an expression for the nth term of the sequence, or they sometimes say determine the, what do they say, determine Tn of the sequence. So the expression for the nth term of this sequence, they mean that they want they want Tn, you see. And Tn, we all know with the general formula of the sequence, it's an squared, the quadratic an squared plus the bn plus the c. They want this formula. This is the standard form of it, but they want us to get the a, the b, and the c, and then we fill it in here to find exactly the direction of this sequence, the equation of this sequence. It's a parabolic pattern, or we can say it's a quadratic pattern. So as you can see, it's a square here. Yeah. So let's go for it then. How do we get this? We first start by getting the a. How do we get the a? We say 3a is equals to, we go for the second difference, which is constant. We take the 4. No, it's not 3a, it's 2a. Sorry, it's a 2a. We use 2a, not 3a. 2a. We use a 2a. 2a is equals to the second difference, which is the second constant difference, which is equals to 4. Then we put the 4. 2a is equals to the 4. Then we divide. Here we want the a. We divide by, okay, it will be 2a is equals to 4. We isolate the a by dividing with 2. We divide by 2. A is equals to 4 divided by 2. It gives us a 2, right? So how do we get b? We use the formula 3a plus b is equals to the first difference. The first number of the first difference is 5. So we equate it to 5. That's how we solve for the b. Please mind that the 2a you must always know that for the a you use 2a is equals to the second difference. For the b you use 3a plus b is equals to the first number of the first difference. Then for the c we use a plus b plus c is equals to the first number of the sequence. Just put it in your head. You must know it by head, because on the formula sheet these ones are not there. They don't tell you how to solve, how to get the A, the B, and the C. You must know it by head. So now we now have our A. Our A is 2. We come here, we put the 3. Wherever there is A, we put 2 plus B is equals to 5. Okay, 3 times 2 gives us a 6, plus B, which is equals to 5. Then we isolate our B. B is equals to 5. The 6 goes to the other side, becomes negative. Then B is equals to 5 minus 6. We all know that's a negative 1, right? So we now have our value of B. So we go for C. How do we solve for C? As I said, A plus B plus C is equals to the first number of the sequence, which is 0. You see? So what is our A? Our A is 2. We just put the 2 there. Our B is negative 1. We put the negative 1. Our C is what we are looking for, and we know we have 0 there. Then we just isolate the C. C is equals to the 0. The 2 goes to the other side, it becomes negative 2. The 1 goes to the other side, it becomes a positive 1. So C is equals to negative 2 plus 1, which is also a negative 1. Please know this by head. 2A, you equate it to the second difference. Then 3A plus B, you equate it to the first number of the first difference. And A plus B plus C, you equate to the first number of the sequence. That's how you get the A, the B, and the C. You must know it by head, because these formulas are not there on the formula sheet. So we now know that, as I said, they wanted us to find this general formula. So Tn, we now know our A, our B, and our C. So we will rewrite it as Tn is equals to, what is our A? Our A is 2. Then we put 2 n to the power 2. What is our B? Our B is negative 1. Then we put the negative n. We know here it's a 1. When it's a 1, you just leave it like this. Then what is our C? Our constant is minus 1. Then we put the minus 1. So they said determine an expression for the nth term of the sequence. This is the expression they wanted. So how do we know we are correct? Let's just go there and test it. Let's go for any number here. This is term number 1, term number 2, term number 3, term number 4. For any case, let me use term number 2. Wherever there is n, I just put the 2. It must give me the number which is on term number 2. So if it's correct, it's gonna give us, okay, term number 2, we just put 2. Then on the end we put 2, because we are looking for term number 2 squared, minus, on the end we put 2 minus 1. It must give us a 5. So you see it gave us a 5, so meaning our expression is correct. So let's go for the third one, which is 2.1.3. 2.1.3, what do they want? Calculate the number of terms in the sequence. Okay, how do we get the number of terms in the sequence? We look for the last term. The last term of the sequence will be 860, meaning the term number of the last sequence will be 860. Then let's find how many terms does it take this sequence from 0 to 860, counting via this 5, 14, this quadratic pattern. So how do we do that? We just equate exactly this into the 860, meaning our 860 becomes our Tn. So wherever there is Tn, we put 860. So because 860 is the last term, so it will tell us, it will automatically tell us how many number of terms are in the sequence. So 860 is equals to, we take our expression, which is 2 to the power, which is 2n to the power 2 minus n minus 1. You see, then we solve for n. N is the number of terms which they are looking for. We solve for n. Then how do we solve for n? Equate to 0, 2 to the power 2n to the power 2 minus n minus 1. We take the 860 to the other side, it becomes negative 860. Then 0 is equals to 2n squared minus n. Then the negative 1 minus 860, it becomes a negative 861, right? So we all know when we now have an easy trinomial like this, we can go for our quadratic to solve it. Then, but remember, when we go for the quadratic, we'll get two answers. So the one with a negative is the one which we are not going to use, because we want the number of terms, and we cannot say, maybe let's say we are counting cars, we cannot say, maybe when we see 3 or 4 cars, we say we 1 2 3, then we say we have negative 3 cars. No, we'll say we have 3 cars. So there are no ways you can count a number, the quantity of things, then you get a negative answer. No. So where whatever answer which is negative we are going to get here, that's not the one, but the one which is positive is the one which is going to be the right one, because it's obvious on a quadratic we always get two answers. Just like a parabola, it crosses the x-axis twice. So this is a formula of a parabola, so it does the same thing. N is equals to negative b plus minus the root of b squared minus 4ac divided by 2a. So we want our n, we come here, n is equals to, what is negative b? Negative, what is our b? Our b, it's a negative 1, as we can see, negative 1 plus minus, what is our b squared? Our b squared will be negative 1 squared minus 4. What is our a? Our a, it's a 2. What is our c? Our c, it's a negative 1, right? Divided by 2. What is our a again? Our a is 2. Then let's get the number of terms. Let's punch this on our calculators. Negative 1 plus the root of negative 1 squared minus 4. A is 2, c is negative 1 divided by 2, a is 2. We get that, what do we get here? We get that the number of terms minus 4 is 2 minus 4. No, sorry, for the c here, for the c we were not supposed to use the negative 1. Sorry for that. For the c we were supposed to use the negative 861, right? Not the negative 1. So meaning, let's cancel this one. We made your favorite uncle made a mistake there, sorry for that. Okay, n is equals to negative, what is our b? Our b, it's a negative 1 plus minus the root of, what is b? Our b is negative 1 squared plus minus the root, oh, what's going on? Oh, plus minus, oh, another stupid mistake. So okay, let's go for it then. Let's see. Yeah, let's just finish this one, the 2.1.3. We now have, let me write it here so that it cannot disturb me again. We have the 0 is equals to the 2n squared minus n minus 861. Then we solve for our n. Our n is equals to the negative. What is our b there? Our b is -1 plus minus the root of, what is our b? Our b is -1 squared minus 4. What is our a? Our a is 2, and our c is -861. It's -861. You see what was disturbing your angle? It's just that here it was mixed with this one. We're still solving, so your favorite angle just went for the one on top, which was supposed to be this one. So we divide by 2. What is our a? Our a is 2. Then let's get the number of terms. So let's punch that one on the calculator. On the C we put the 861. Then we get n is equals to 21, or let's use n. So, okay, let's see, n is equals to 21, and n is also equals to, let's see if we put the minus sign on our quadratic there, we get the -41/2, which is not going to work, right? Because we are dealing with the quantity. The quantity, we want the number of terms, so there are no ways we can have -41/2 terms. So this one, meaning n is equals to 21 and n is not equals to -41. So we can conclude that the number of terms, what was the question? The question was to calculate the number of terms in the sequence. Okay, the number of terms in the sequence is 21 terms. Hope you understood. Yeah, so don't mind this mistake. We all make mistakes, mathematics is a bit dodgy sometimes. So yeah, please try this one. And yeah, it was just for the first one, as we are getting into number patterns, just to warm up our minds. We go for arithmetic and geometrics and the ones which are much more complicated, but this one was just for warming up our brains. Yeah, please subscribe and follow for more content. Please subscribe and follow and share with others so that we can push our content, and your favorite angle can continue putting more and more so that we can have more fun in mathematics. Yeah, please try this one. Make sure you understand.